Maharjan. I'm presenting project 177, that is replication of the experiment in the benchmarking deep learning architecture for predicting readmission to the ICU. And the team ID is I2 and the group member is just me, Umesh Maharjan. So I'm going to cover all the listed here from introduction to the experiment and the results. Introduction. The original paper described different deep learning models that are applied for predicting the risk of readmission within 30 days of discharge from the ICU based on the clinical history of patients. And readmission to the ICU cover lots of hospital cost, and US gross national product are directly linked to ICU expenses. That's why I chose this paper to reproduce. Objective. The goal of the project is to reproduce of the result that is presented in the original paper, and the data is obtained in MIC. So I use the same method and same experiment to get the result. Successfully run the different deep learning models and compare the result for predicting the risk of readmissions, and provide enough details and hidden argument or challenges on this experiment. I also did some hyperparameter tuning to match the result. Data source. The publicly available MIMIC3 de-identify health data association with around 61,000 ICUs stay and around 46,000 critical care patient is used on the training and test the model. After cleaning up the reinsurance data, the final data only associated with 45,298 ICUs stay for 33,150 patients were there, and rest of the exclude ICU stay because of the patient were there during the ICU stay, or because the patient were 18 years older at the time of charge, or patient were dead within the 30 days from discharge without being readmitted. So depending on the patient readmission with 30 days for discharge, 5,495 were labeled as positive and 39,803 as a negative. Methodology. So we use a supervised learning to predict the patient discharged from ICU will be readmitted. So as in the figure at the right side, the time-aware code embedding were computed in three different manners. MCs with the time-aware attention are based on the continuous bag of word model to determine a code's context. Embedding layer with concatenate elapsed time approach optimize and embedding matrix at the same time as the other parameter of network and concatenate the elapsed time to result. Embedding layer with near ODs, the approach adds model the dynamic in the time of computed embedding using neural ODs. The embedding of a code recorded before discharge was computed by solving a problem by multi-layer perception. And here for the model description, I use several deep neural network architecture, and the model itself includes different neural network component embedding, attention layer, logistic regression layer, and the architecture. So embedding is a real value vector. It is formed by mapping of diagnosis and procedure code with medication and vital sign code. Attention layer or mechanism assign higher weight to the most relevant embedding code, and recurrent layer iterate process input sequence of code. Logistical regression layer, that's at the bottom of the right. This layer provides the prediction to the risk of readmission to the ICU within 30 days from discharge by concatenating the score to the vector of static variable and pass to fully concatenate layer with a sigmoid activation function. So hyperparameter, I use the two sets of hyperparameter. One is the original that's closely matched with the original paper, and the other one is the starting point so that I can validate my result. So the right one is the original one that's very closely matched with the paper result. Number of batches I use 128, number of epochs 80, learning rate 0.001, maximum number of steps 1000, bootstrap sample 100 on my final experiment. During the computation, I use my MacBook Pro 2.3 gigs 8 core Intel Core i9 with 16 GB of RAM, and the entire algorithm is developed in Python using scikit-learn, PyTorch, TensorFlow, NumPy, Pandas, etc. So during the experiment, I used 90% of patients were randomly divided into training and validation, and 10% into the test sets. Training were terminated after 80 epochs since overfitting of the training data started. So I also did some hyper tuning to match the result. So this is the following result were achieved on running on different models with the tune hyperparameter, and I found that OD plus RNN has the highest precision as it is in the original paper. It's a 0.335. It's very close to the original paper, and I can see that logistic regression has a very low average precision. I also generated confusion matrix for OD plus RN model with optimized result that give the clear visualize for OD plus RN model. Discussion, like in general, the predict accuracy of the different deep learning models was close to similar, but considerably better than logistic regression, as I mentioned. So this experiment was several limitations. Since all the data is shifted due to PHI, it was not possible to ascertain which patients were admitted after 2001 and had at least 12 months of the prior data. So if I could have a better hyperparameter, then I could get exact or very close to the result that's produced in the paper. And in the paper, it didn't mention the hyperparameter at all. So this is a snapshot of my execution when I did the experiment. We can literally see how it is executed and get the result. So this is the references. You can go there and link to get the detail. Thank you.